Hello class, welcome to another screencast for Miss Jamelin's Science 10 class. Today we will be covering the concept of velocity. We will be starting with an introduction to velocity. Moreover, we will discuss the vocabulary associated with velocity, such as speed, distance, displacement, time, and of course, velocity. After, we will be discussing the formula used to calculate velocity and speed. There is a practice problem midway through the lesson, so have a pencil and sheet of paper ready. Introduction. Italian physicist Galileo is usually credited with being the first to measure speed by considering the distance covered by an object and the time it takes for the object to travel that distance. Galileo defines speed as the distance covered per unit of time. Vocabulary breakdown. Scalar versus vectors. The motion of an object can be described using two different terms. Both ways are valid ways to describe the motion of an object, but they are not interchangeable, nor are they equivalent. To describe the motion of an object using a scalar quantity is to describe it by a magnitude or a numerical value alone. However, to describe the motion of an object using a vector quantity is to describe it by both its magnitude and its directionality. In order to denote the difference between scalar and vector quantities, you simply put a small arrow above the symbol of vector quantities. Here are some examples of scalar and vector quantities listed in the graph. Vocabulary breakdown. Distance versus displacement. Although the terms distance and displacement seem to be talking about the same thing, they are actually very different concepts. Like we said before, although two terms may seem to mean the same thing, if one of them is a scalar and the other is a vector, they can hold radically different meanings. Distance is a scalar. It is the total amount of space covered by an object. There is no concept of directionality with regards to distance. In contrast, displacement is a vector where direction actually matters. Displacement is the amount of space moved from an original location. This may not seem to matter much, but look at this example. Person A walks to the right 5 meters and walks back to his original location by walking 5 meters left. Now this person has traveled a total distance of 5 meters plus another 5 meters, making the total distance traveled to be 10 meters. However, when calculating the total displacement that person A has traveled, we ask the question, how far is this person from his original position? And the answer to that question is 0, because the person ended up in the exact position he started in. Another note to make about distance and displacement is that they share the same units. The most common SI unit used for both these terms is the meter. However, any measurement of distance would also be applicable to displacement, such as kilometer, nanometer, micrometer, picometer, feet, yards, inches, and etc. However, when you write the units for displacement, add in brackets the direction of the displacement, such as 5 meters, brackets, east. Note: distance is denoted by a lowercase d, and displacement is denoted by a lowercase d with an arrow on top. Distance and displacement may seem to be very similar concepts, but with further investigation, we can tell that they are actually quite different in their definitions. Vocabulary breakdown. Time. Time is a scalar quantity that can be measured in seconds, minutes, or in hours. It is denoted by the lowercase t. The specification of the unit of time depends on the context in which it is being used in. Say, for example, you are measuring how long it took for a 10-year-old boy to run down the hallway. You would probably use seconds rather than hours. However, if you were measuring how long it took to drive from Calgary to Edmonton, you should choose hours as your unit of time, rather than seconds. It all depends on the context. Vocabulary breakdown. Speed versus velocity. In the same way, speed and velocity are also similar in their definitions, but are separated due to directionality. Speed is a scalar property, and is defined as the total amount of distance covered in a specific amount of time. Direction of motion does not matter in speed calculations. In contrast, velocity is a vector property, and direction plays a huge role in its calculation. Velocity is defined as the total displacement covered within a specific amount of time. Note that velocity is calculated with a vector quantity, displacement, to yield a vector, and that speed is calculated with a scalar quantity, distance, to yield a scalar. Likewise to distance and displacement, speed and velocity also share the same units. The most common SI unit used for speed and velocity is meters per second, but any unit of speed can be used, such as kilometers per hour, nanometers per day, knots, and etc. Speed is denoted by a lowercase v, and velocity is denoted by the lowercase v with an arrow above it. Looking back at the example used for displacement and distance, at what speed and velocity is person A traveling at if it took him 5 seconds to complete the 10-meter distance? In order to complete this question, we will need to learn two formulas. Formula. In order to calculate the speed traveled by person A, we must learn the following formula. Speed equals distance over time. By dividing distance with time, we are calculating the total distance traveled in that amount of time. The most common unit of distance is the meter, and the most common unit for time is the second. Therefore, by dividing meters over seconds, the units of speed become meters per second. In order to calculate the velocity traveled by person A, we must learn another formula that is essentially the same as the one we just learned. Velocity equals displacement over time. The only difference in this formula is that speed is replaced by velocity by drawing the arrow above the lowercase v, and distance is replaced by displacement. Using these two formulas, attempt to calculate the speed and velocity of person A. Now remember, the person started off at location A and walked 5 meters to the right and 5 meters to the left, right back to where the person started. He took 5 seconds to do this. Pause the video and attempt this problem. Once you have tried it, continue the video. Have you attempted the question? In order to calculate the speed of person A, we need to find the distance traveled and the time it took for person A to travel that distance. The distance traveled was 10 meters, and it took the person 5 seconds to travel that distance. Therefore, 10 meters divided by 5 seconds gives us 2 meters per second. In order to calculate the velocity of person A, we need to find the total displacement of the person and the time it took for the person to be displaced. The total displacement was 0 meters due to the person returning to the original position after moving, and it took the person 5 seconds to do so. Therefore, 0 meters divided by 5 seconds gives us a total velocity of 0 meters per second. This makes sense, because if the person was not displaced, then there would not be any velocity for us to measure. Summary. Now, to summarize what we learned, we covered scalar versus vector. Scalar has magnitude, vector has magnitude and directionality. Distance versus displacement. Distance is a scalar measurement of space covered, whereas displacement is a vector measurement of space away from the original starting position. Speed versus velocity. Speed is distance over time, whereas velocity is displacement over time. Moreover, we also discussed the units of time and the context in which to use them. And finally, we finished with the two formulas for speed and velocity, and we calculated an example.